Today's notes are on determining if a relation is a function or not. So we should probably start by defining what a function is. A function is defined as a relation, so any relationship between x and y, but it's a special one in which each x value has one y value. Each x has exactly one y value. So this here is an example of a function. We're given this table. Notice the x value of -2 has one y value, 1. X equals 5 has one y value, 2. X equals 6 has one y value, it's 8. 9 has one y value, 3. If it looked like this, maybe I have another point here, 10, 3. The x value of 10 has one y value, 3. This is still a function. Even though that y value was the same as this y value, each x has exactly one y. If that's a little bit confusing, let's take a look at one that's not a function, and hopefully that'll start to help clear it up. The table that's given here down at the bottom, I'm going to move it off to the right here. This one is not a function because the x value of -2, x equals -2, has two different y values. X equals -2 has a y value of 5, and x equals -2 has a y value of 7. One x has two y's, definition of a function. Each x has to have one y. This one is not a function. And it only takes one x value to repeat for it to not be a function. So let's take a look at a couple examples here. We are trying to determine if each of these is a function. So we are given the xy chart. We have points at 1, 5, 2, 6, 3, 7, 4, 11, and 1, 2, and -3, 4. So when we are checking to see if something is a function or not, we want to see, are there any x values that have more than one y? If there is, then no, it is not a function. So let's start with the top x value, 1. X equals 1 has a y value of 5, and x equals 1 also has a y value of 2. Notice I have two x values, one x value, x equals 1, that has two different y's, 2 and 5. We can stop right there and say no, it is not a function. Part B, new xy chart. We have points -4, 2, 6, 2, 7, 2, 19, 2, and 25, 2. And again, we are asked the same question. Is this relation a function or not? So again, we want to start checking the x values. X equals -4. X equals -4 only has one y value, 2. X equals 6 has just one y value, 2. It happens to be the same y value as up here. That's okay. Each x has one y. X equals 7 has one y. X equals 19 has one y value, 2. X equals 25 has one y value, 2. Because there are no x values that have more than one y value, yes, this is a function. It's important to remember that in order to be a function, we cannot have any x value repeat. The x value should not repeat. If any of the x values repeat, then it is not a function. So let's look at part C. Again, we're given a table. This one's set up horizontally. We are given an x value of 7. We want to see, does that x equals 7, does it repeat? And yes, it does. It repeats right there. 7 has two different y's, 11 and 8. Because the x value repeats, we can stop right there and say, no, it's not a function. If any of them repeat, it's not a function. Part D, we are given a mapping diagram. A mapping diagram, remember, it shows us the relationship between an x and a y by listing the x's in one circle and the y's in another circle. I guess they're more ovals than circles. And then a line that connects the two. So this is showing that x equals 5 has a y value of -1. Notice x equals 5 only has one y value. X equals 5 is okay. X equals 3 only points at -1. It only has one y value. That one's okay. X equals 2 does not repeat. It only points at 8. And 6 only points at 8. This one, yes, it is a function. If it looked like this, now the x value of 2 has two different y's, 8 and -1. In this case, it would not be a function. So everything we've been checking so far is either a table or a list of ordered pairs or even a mapping diagram. Now we want to take a look at if a graph is a function or not. To check to see if a graph is a function or not, we are going to complete what is called the vertical line test. The vertical line test. The way it works is we take a vertical line. Remember, a vertical line is a straight up and down line. If a vertical line passes through the graph more than once, if any vertical line passes through the graph more than once, then we can stop and say, no, it is not a function. So I'll give you a minute here to write down the vertical line test and also sketch a quick graph of that parabola into your notes. Again, vertical line test. If any vertical line passes through the graph more than once, then it is not a function. So sketch it in your notes there. Draw the little parabola. Looks like that. And then what you're going to do is take a vertical line. You can use your pencil, would be a good thing to do. Make it go straight up and down on the graph. Start on the left side of the graph and start moving it to the right. And what you're looking for is to see if at any time, if that vertical line passes through the graph more than once. So like right now, that vertical line only touches the graph one time, and it's right there. So that's okay. We're looking to see, is there anywhere that it touches it more than once? Notice right here, it's okay. It's only touching it that one time. Right here, it's just touching it once. No matter where I put that vertical line, it never passes through the graph more than one time. Because it goes all the way through the graph, we can say that yes, it is a function. Let's try another one. We'll come back to that one. Yeah. Let's try this one. Example, I think we're at example 3. So we have a circle here. Let's make that graph a little bit bigger. We are asked, is this a function or not a function? We take a vertical line is up and down. We start on the left side of the graph and we start moving it to the right. And if we ever find a time that that graph or that line passes through the graph more than once, like this point right here, notice this line touches the graph right here, and it touches the graph right here. If there's any vertical line that touches the graph more than once, we can stop immediately and say no, not a function. This one is not a function. Notice this x value of 3/4 about has two different y's, one up here and one down here. That's what we're checking with the vertical line test. All right, let's backtrack here. Let's check to see if this is a function. This is called a cubic graph. It's a little curly one. If I take that vertical line and I start on the left side, I'm looking to see, is there anywhere that this vertical line passes the graph more than once? Notice no matter where I put it, it only touches the graph one time, and so on. This one is a function. Example 5, similar to the other ones. This one has just points, but we do it the same way. We take our vertical line, we start on the left side. Here, it only touches the graph one time. Only touches 1 point. Only touches 1 point. Only touches 1 point. Touches 1 point. Touches 1 point. Yes, this is a function. If it looked like this, we would take our vertical line. That's okay. That's okay. Now it touches 2 points. Now it would not be a function. So again, the original graph like that is a function, yes. I want you to try these couple. Sketch a couple graphs. I want you to decide if each of these is a function or not. Let's go with that one. Let's go with that one. And let's do an XY chart. So I want you to pause the video, quickly decide if each of these three are a function or not a function. Once you think you have them and everybody's finished, you can play the video, we'll talk through them, and that'll be it for today's notes. So for the first two, because they're graphs, we complete the vertical line test. I start on the left, and I'm looking to see, is there anywhere on this that it touches the graph more than one time? And I go all the way through the graph, and there's nowhere that I can put a vertical line where it touches the graph more than once. So yes, this one is a function. Whereas number 2, right here is okay. It's okay, it's okay. But once I get here, it touches the graph more than one time. It touches it here, here, and here. This one is not a function. If we're given a table or a list of values, what we're checking to see is, does any of the x values repeat? It does not matter if the y's repeat or not. What only matters is if the x's repeat. This one, I've got an x value of 2 that has 2 different y values. My x equals 2 repeats and has a y value of 6 and a y value of 5. So no, this is not a function. That's all I've got today. I'll see you guys next time.